The last part of question 3 is to write the main program for the kitchen timer so that it operates as described in the beginning of the question. Some guides given below, such as to declare global variables and system initialization. Take note that there is an error here. This variable should be start flag, not timeout. Apart from the function written previously, we are also given another function called readPBs. This function checks the push button and return the value according to which push button pressed, as shown in table 3. Let us reorganize the information needed to solve this question. First of all, let's put down all the functions written previously. In question 3.1, the function on buzz, which turn on the buzzer for n seconds. Then we have this time to display the global variables minute and second on LCD. Next is the function timer2init, which initializes timer2 to generate regular 20 millisecond interrupt. And lastly, we have TMR2ISR that keeps track of the time, increasing second and minute accordingly. As ISR will be called automatically when the corresponding interrupt occurs, this function will not be seen being called anywhere in the program. We are also given a function readPB to detect which push button is pressed. The function returns 0 if PB min is pressed, 1 if PB start is pressed, and so on. What we need to do in the program is as follows. Firstly, we need to declare global variables minute, second, and start flag. Global variables are variables that can be shared by different functions, and so they have to be declared outside the function. We use sign char for minute and second because in question 3.4 they will be decreased below 0 or go negative. For start flag and e-counter, all data types char or integer, signed or unsigned, can be used. Unless the global variable are assigned with values during declaration, they will be initialized to 0 by default. Next, we initialize the system. This is the first thing to run in the main program. Here we initialize LCD and timer2. Once timer2 init is called, interrupt will occur regularly at every 20 milliseconds, and so is TMR2ISR. Notice that the operation will keep repeating from step 3 when it reaches step 6. This implies that this operation will be in a while loop. Step 3 states that LCD should display 00 initially. We can use this time to do this, but we don't have to because the timer ISR will call this function. Remember that timer ISR is the interrupt service routine which will run once every 20 milliseconds. So effectively, the time display will be updated at every 20 milliseconds. It seems like we need to use if for step 4 to step 6. For example, if PB second is pressed, variable second is increased by 1. If PB min is pressed, variable minute is increased by 1, and so on. Before that, we need to read the push button. We can use read PBs for this task. Here we use variable PB to store the return value, and so we need to declare variable PB. We will then see if PB set is pressed. This is done by checking if the return value is 2. If it is, we will increase variable second by 1. After the increase, if it reaches 60, reset to 0. And that's all the action needed when PB set is pressed. We do the same for PB min. Here we see if the return value is 0, if it is, we will increase minute by 1. And if it reaches 100, we will reset it to 0. And that's all the action needed for when PB min is pressed. Next, we check for PB start. That's when the return value is 1. If PB start is pressed, we want the kitchen timer to start counting down. Referring back to question 3.4, this is when start flag is 1. So we set dit to logic 1 in the main. And when the count reaches 0, turn on buzzer for 10 seconds. Here we see that when kitchen timer counts to 0, ISR clear start flag to 0. So we need to wait till start flag become 0 before turning on the buzzer. Finally, we check for PB reset. That's when the return value is 3. If it is pressed, reset the kitchen timer to 0. That is to clear variable second and minute to 0. To repeat from step 3, we simply close the while loop. While this program looks okay, the reset button will not work when the program is waiting for start flag to become 0. So we need to expand this part. In order for the reset button to work anytime, we need to check for the button while waiting for start flag to become 0. So we call read PBs for this purpose. If the return value is 3, it indicates that the reset button is pressed. We clear start flag so that it will exit the while loop. We do not need to clear minute and second here because when it exits this if here, it will go on to this if, which will clear the two variables. Here we may not want to turn on the buzzer if the reset button is pressed. So we check that only if PB reset is not pressed, then we turn on the buzzer. That's all the main program for the kitchen timer.